All right, folks, we're going to give people just a few minutes to get here. Before we get started, any other questions that you have about our session on Monday? Be sure to check your email for, if you're a Mac user, you'll want to go to the repo. Miranda is putting information on there right now of how you can get to Microsoft Bing. And in case you were wondering, yes, absolutely. Microsoft is using Bing GPT, their early access to GPT-4 to leverage people into using not just Bing, but also using their Edge browser. So if you want to use Bing Chat, you will need to download Edge, and it doesn't matter if you're on a PC or if you're on a Mac, you'll need to download Edge. You'll also need to sign up for a Microsoft account. And one weird thing, if you're at Vanderbilt, is that we're finding that for some reason there's something that's not quite working with trying to use a Vanderbilt account to sign up for a Microsoft or to get to your Microsoft account. There's some permissions or something, and so you can't get to Bing using that. So if you're on Mac OS, if you're at Vanderbilt, follow the instructions that you're going to find either now or find shortly on the repo about how to get to it. All right, and we're going to get started up in about 1 more minute.
All right, the instructions for accessing Bing Chat should be on the AI Summer repo now at the very bottom of the README.
Excellent. Very, very good. Thank you. Okay. All right, we'll give folks about 1 more minute to get in. All right. All right, we'll get started. So in a moment, a couple of quick housekeeping notes. Be sure to check out the chat. If you're part of a research group or a special group like DSSG or Research IT, remember to prepend your name. So you probably need to do that again. So if you're in, this will allow Umang to put you into the right breakout rooms, because we'll need to. And Umang, did they exist from the previous time, or did they disappear?
They did disappear.
Okay, so he's going to be recreating those, and then we'll be doing that again. I'm going to be speaking. I'm going to be speaking today up until about just before 10:30, and then I'm going to be giving another workshop elsewhere. So for the last half hour of today's session, we're going to be talking about. You're going to get an introduction to other large language related models, in particular diffusion models. So these are another type of generative model, but that generate images in a very interesting way. We're going to have Abigail Picciolanti. Dr. Picciolanti is a postdoc at the Data Science Institute, and you can wave if you want to, Abby. And actually, Abby, I think I need to make you. No, you're already co-host. You're already set. So I will not be around for the office hours, but do feel free. We will have office hours, and if you have a specific question for me, feel free to reach out. Be happy to answer any questions that you have there. All right, we're at 9:03. Let's go and get started. Welcome to day 2. So week 1, day 2, of the AI Summer. Remember, we will not be meeting on Friday. Friday is Vanderbilt's graduation. And as a matter of fact, I'm going to be right in there. I'm going to be a marshal this year, which should be a lot of fun. So we'll either be on the alumni lawn or we will be in Bridgestone Arena. We'll have to see if it's raining, but we're going to be busy doing that. So we're going to meet again on next week. Next week, we're going to start talking about AI assisted coding. So along with the rise of generative AI, we've had an absolute revolution in the type of coding that you can do assisted by AI. We've had things like Copilot for a little while. Copilot, also transformer-based assistance. And with Copilot, you can do things like start a function and describe what the function is supposed to do, and it will fill in the rest of the function. And it's very, very, very good. But with ChatGPT or with other large language models in this chat approach, instead you can describe what the program should be doing, what language it should be in, approximately what approach it should take, and it can generate an entire program or significant parts of programs. So this is a very different kind of an approach. So we're going to be teaching that next week, and we're going to be teaching it so you can, in turn, program generative AI models using LangChain that we'll be talking more about next week, or you can program other transformer models. So this is, yes, it's very meta. This is using AI assisted coding to help you build AI solutions. The following 2 weeks, the last 2 weeks, so weeks 3 and weeks 4 of this session of this AI Summer will be all about building solutions using LangChain, and also building other types of transformer models, training them either from scratch or doing domain adaptation on them. So any questions before we start a brief review of our last session about any of what I just covered? Audrey.
Hi, I have a maybe weird random question. So I'm having some computer problems where my keyboard is like making double letters. So when I'm typing, it is like very much filled with typos consistently. So I'm just curious, do you know if these programs can handle typos, or will they only work if like typos are corrected?
That is a great question. And it will be model dependent, right? And here's the funny thing. And Wesley, as you just pointed out, what am I likely to say? It's an empirical question because there are some models are trained on just purely dirty data. They grab whatever they could get and they trained on it. And those models are actually going to be more robust to those types of noisy situations. Plus the way that, but the way that it does tokenization, it may also cause it a problem. So it depends on how much of the noisy data that they've seen. Remember that this works not just on the character level, but at the token level. So if you putting in an extra character there sort of ruins a word, and so it goes from being a single token to being multiple tokens, then that's going to be a detriment, right? And it's not going to be doing an extra step where it cleans up what you've done before it does it. Instead, it's going to treat it, oh my gosh, it's like 5 different tokens to represent this thing because there's an extra P in here. If the model was trained on noisy data, then it's going to be robust to that and will automatically just represent that even very early on in the embedding of, oh, they meant to type this, here's the embedding, and then it doesn't matter. But let's say that it's clean data, that it will have never seen that before. And so then if you have a very short context and you have a typo in there, it's going to have great difficulty. And again, that'll be ameliorated if you have longer context, because it'll be very clear from the context that you've provided what it is. So I hate to say this, but it depends. You're really gonna have to try it out to see how well it works. My guess, ChatGPT 3.5, ChatGPT is gonna be not very good. Any of the models that have been trained on very clean data, like my guess is that Bloom might not be very good at it because we're very careful about the data they fed to it. And that involved some cleaning, but not a whole lot. But you're really gonna have to try, but that's an interesting question. Michael, since we were talking about training here, Can you also explain the difference among zero touch, a few touch, and fine tune? Okay, zero shot, few shot, and fine tuning. Yeah. So let me do. Michael, can you remind me of this in just a moment? Because what I'll do is I'll start reintroducing what we did last week, and then that will lead to this. So if you can remind me of this in just a moment.
Sorry. Yeah,
Yes,
absolutely.
Jay. Thank you so much. Jay.
Hi, I'm building on top of the typo issue. I was wondering, when we're modeling something, it predicts the next word. But if the model is trying to predict the next word. But
The
what
generative.
happens if we type it?
Yes.
Yes, when we provide something with a very broken grammar, or just that one that goes forward and backward, how does it deal with that to understand it?
So we've actually been talking about just one kind of transformer. And that's what I'm going to show you in just a moment, is that there are multiple types of transformers. So this type of transformer is trained specifically where it only gets to see words that came before. And so it's called causal modeling. And so its main task is predicting the next word. There are other types of transformer models that get to see both sides of the context. So it's a different kind of training, often associated with a different type of architecture that is not trying to predict the next word, but simply giving you embeddings. So it's returning directly the semantic representation that it's come up with. And you'll see that in just one moment as well. So again, it's been trained on so much data that even though context afterward might be useful, you can tell a lot by what came before. If you need something where you need to deal with the meaning of something that comes from both directions, then you're probably not doing predictive modeling of the next word, right? You're probably not doing generative. So you probably need one of the other architectures that we're going to talk about right now. All right. Other questions? Okay. Prasanna, all right. So ChatGPT was obviously trained on some good dirty data. That's fantastic. All right. Let's go ahead and take a look at sort of the whole picture here, because we've only been talking about generative AI. So I'm going to show you a picture of the original full transformer. Okay. So here is the original full transformer. This is what it looked like. So it had two different parts. It had an encoder part and a decoder part. This gets a little bit confusing because people think about, oh, encoding, decoding, and they think about UNet and things like, if you're a CS person, think more broadly. So in this case, you have an entire network whose job it is to come up with these hidden states. And then that information is fed into another transformer whose job it is to simply predict the next word. So it turns out that these are almost two identical types of transformers, just they're communicating with one another. And this was the original. This is called an encoder-decoder transformer. And again, I'm serious, they're almost identical. When you take a look at the code between them, there's a little bit of difference in how the attention mechanisms work. And then there's this attention mechanism has extra parameters so it can learn from the other. This original transformer was designed to work in the following way for translation. You put English in here, it comes up with a representation of this. It doesn't predict the next word. It just comes up with a rich semantic space where this information is represented, this sentence is represented. Then that representation is shared with another network that is trained on, in this case, German. And so it takes the German phrase and iteratively feeds through. So it's feeding through, it's getting information from here, and it's feeding through and then generates German on the outside. That's encoder, decoder, transformer, still dead useful. We can use them all the time for many different things. Generative AI is not the end of the story. Generative AI is only a particular type of transformer model. And it is essentially just this part, the decoder part. Because remember, with the decoder part, what it's really doing is generating the next word. So GPT, which was the first early one of that, and GPT-2, and now GPT-3 and GPT-4, are all of this type of architecture, not even using the encoder part. Now all it's doing is just trained on given multiple language. So how do you translate? We'll train it on English and French and Mandarin, train on all of it, have it predict the next word, have it learn what the indicators are that it's in one language versus another language, and just guess what the next. Now that meant that you had to make the decoder stacks huge. In order to get that capability, these had to grow immense. And that's why ChatGPT 3.5 is 1.75, it's 175 billion parameters, because the feed-forward networks got very big so it could encompass all this information. This makes them very flexible. This makes them very knowledgeable about the world, because it has to represent the world to make all of this work. That is the decoder network. So when you talk about generative AI, or you talk about ChatGPT or a chat model, you're talking about a decoder transformer model that has a simply completely outsized decoder stack that's just gotten very big. Architecturally, it's the same. Transformers are powerful general purpose learners. So to get them to be able to learn more, you just grow the decoder stack. There's yet another kind of transformer though, and that's called the encoder. So you can take just this blue part, split it off. This is called an encoder transformer. So BERT that you might have heard about is an encoder transformer. So still useful. They tend not to be as big because you're not trying to train it on all the knowledge on the internet. Instead, you want it to understand English, maybe multiple languages, but those tend to be smaller and sort of purpose built. So you train it, you can train it from scratch. You know, we've trained one from scratch in collaboration with VUMC. You know, it takes a little bit of time, but we have the compute to do it. And it generates the hidden states, and you can use those hidden states to classify documents, to extractive question answering, to, you know, a wide variety of things. So 3 different architectures: encoder, decoder, transformer, the original, and it's still in use. BART is an encoder decoder. Whisper is an encoder decoder. Decoder only, that's ChatGPT, GPT-4, all of those are decoder only, just the red. And encoder only, that's the blue part, and that's going to be things like BERT, Roberta, and others. All right. Okay, great. And if you all can, do I need to switch over to my other network, or are we good?
Some people are saying it is breaking up a bit. It's not bad for me. So if it's bad for some people, I don't know, but
okay, great. Let me, if it gets bad, break in, Miranda, let me know, or whoever, if you can, you know, or Miranda, break in, text Miranda, let her know we can break in, because I will switch over to the other network, but it's a little bit risky. All right, questions about transformers. How does a decoder trained on German understand the embeddings from an encoder trained on English? Good question. Think about when you get to that, one way to think about it is the latent space, but it's the semantic space. If you train these at the same time, then they get a dual compatible representation. They're building, you know, at the higher level, they're building a representation of the world that is consistent. You have to train them together. So you can't just match them up willy-nilly and assume that they're going to match up. I mean, I think there's some interesting ways to do that. That's a research question, but you train them together, and then the world representation that they have is the same. So for example, if I tell you, you have this thing, I don't know the name of it, but you have this thing, but you can add it to ground up coffee. And if it's hot enough, then it's good. And the same thing, you can float a ship on it. Does anybody have an idea of what that concept is? Oh, by the way, also, okay, water. Okay, how about in French? That concept, what is that concept in French? Great. Spanish. So I didn't have to tell you, translate this to. I simply gave you the concept and then you knew what it was. So if you are learning those at the same time, then those concepts match up. So you can imagine if you're training a model in multiple languages, those concepts match up. Eau, aqua, water, they're all going to end up here in that conceptual space. So that's how the translation happens. Raymond.
Yeah, given how transformers have to be set up, is there anything current or looking forward that would basically be a Swiss Army knife transformer setup?
Frankly, they're all Swiss Army knives,
Yeah.
right? I mean, they're all general purpose learners, and it really depends on what task you're trying to do as to which one would be most appropriate. Again, the encoder, the decoder, I'm sorry, the encoder only, the encoder decoder, you can kind of do more specific tasks with a much smaller network versus decoder only, where it's a jack of all trades. You know, maybe it's the best, and some things it absolutely is the best, but document classification, you know, you can use a decoder only. You could use GPT-4 for document classification, or you could take a teeny tiny little, you know, BERT model and get as good performance. So you have to think about what you want to do.
Yeah,
and think about this specialized, models like AlphaFold 2, actually really small transformer models. The transformer architecture that in the attention and the feed-forward net is an amazing, powerful learner. And you don't have to be big for it to learn. You do have to be bigger for it to learn massive amounts. But I mean, Hassan, you can speak to the success of that tiny little AlphaFold 2 transformer.
Concise qualifier is, hypothetically, if I wanted to be able to run through the entire corpus for this AI summer using one transformer setup, if for context, if that would make it, if there's a more concise answer or a better answer than knowledge may vary.
They might. Tell you that, yeah. And Raymond, bring that question to the office. Oh, and all right. Let's see, and let's see, and I can't see your full name. Faculty DR, could you describe a little bit what you mean a decoding phase by definition? We'll get back to that. All right, I am going to I'm going to try to switch over to my other network, okay? Since a couple of people are mentioning that it's getting a little bit laggy. So what I'm going to do is I'm going to set you all up for a breakout room. So we're going to do a few things. I'm going to get you into a breakout room in a moment. Let me answer Laura's question first. Is the defining feature of all transformers that they use backpropagation? Actually, that's not unique to transformers. That is any deep learning model. That is the learning mechanism. Because really, you can think of all deep learning models as a collection, a massive collection of parameters of different sorts. One type of parameter is the weights that connect the nodes for a feed-forward network. And that's usually where the learning occurs. Information is stored in a feed-forward network. But there are other parameters as well, like the attentional weights. We got a little glimpse of that if you were in the office hours yesterday, day before yesterday. All of those weights are learnable. Any parameter in a deep learning network is learnable. Hyperparameters are set. Parameters are learnable. How do you learn them? Backpropagation. But that's true for any deep learning. Now, what really sets transformers apart is the fact that they use attention combined with a feed-forward network in stacks. Transformer, you know, so you have attention, and then you have feed-forward network, and then you have attention, and then feed-forward network, and then attention and feed-forward network. So they're stacked like that, and that's one of the defining features of it. All right. Now, let me go ahead and introduce prompt engineering. Let's go back. I'm going to share my screen one more time. And let's go back to the decoder only network that we've been playing with. So recall that that what's happening here is that we have context and then we're getting something out, right? So how do you steer what you get out of a network? I'm sorry, how do you steer what you get out of this transformer, this decoder transformer, this ChatGPT? Well, you could steer it by giving it more training. And so if you wanted it to know more about something that you want to talk about, you could train it more. But that's not really an option with a 175 billion parameter model, especially one that's owned and run by somebody else. And you might remember that if you've done reinforcement learning from human feedback, that's not really an option anymore. So how do you get it? How do you give it and steer it? You do it through context. So prompt engineering is currently the art, will become more of the science of determining what needs to go into the context in order to do next word prediction better. And at the very beginning of this, people thought of prompt engineering as being, as prompting as just like, here's a magic prompt for you. You know, this prompt works really well. And people were swapping prompts back and forth. But in fact, you can think about them a little bit more systematically. Did folks have a chance to take a look at the paper and to give a thumbs up if you got a chance to take a look at the paper? Okay, good. All right, fantastic. So what we're going to be doing is we're going to take a closer look at some of these. But keep in mind, really what we're doing is we're trying to give enough context and so we can steer the model. Think about everything that's in that decoder stack. These are huge models. So ChatGPT is 175 billion parameters. GPT-4 is an unknown number of parameters because they haven't shared that yet, but appears to be much larger and much more capable. So in there, if you can just get it to concentrate on the right part, then you can get it to do the things you want it to do. So I'm going to share with you a document that I've prepared actually for a talk that I'm giving in just a little bit. And these are travel agents. These are several hundred travel agents that are here in Nashville. And as you can imagine, you know, they're pretty concerned about ChatGPT and what this means for their work. So I'm introducing them to different types of prompts. So one of the prompts that you ran across was called a persona prompt. And the idea here is that by giving a persona to the model, you let it know what is important contextual information. So this is, yeah, and Eric, oh, absolutely. I mean, there's some good news for them, and that is that they can leverage their own information to have a personalized approach, but automate a whole bunch. But yeah, but no, they're very concerned. So when do you use a persona prompt? Well, if you already know exactly what content you want to have to be relevant, just put that into the prompt. But if you don't know exactly what is important, but you know who you would ask, that's when you use a persona prompt. So you may know that you need to have a really good editor to take a look at something that you've just written, but you really don't know everything that they might bring up, you know, dangling participle, you know, passive voice. I love passive voice. It sounds more scientific. You know, you may not know everything that an editor knows, but you know that you need one. Great. Do a persona prompt. You are an editor. And that what that does in the model then is it emphasizes, out of all the massive amounts that it knows, it emphasizes the part that's most important and most relevant for your work. So that's a persona prompt. Similar thing with flipped interaction. You may not know what you need to give it, and there's not someone that you could sort of know that you would ask. So instead you ask the model, you flip, you say, ask me questions until you have enough information to carry out this task. So you use this one when you know what a task is supposed to be. Then it can give you, if you know what what you're going after, you have a goal in mind, but you don't know what information you need to get, that's when you can ask for a flipped interaction. And this turns out to be a very powerful one. And remember, you can always mix and match these as well. So what's going on here? Again, you want to give more context here. So this is a two-step process, right? So the first step, the first pass is to say, ask me questions so I know what context to give you. So it figures out based on the task that you have, what questions you should have. It generates that for you. You then feed that right back into the context along, and so it can continue with answering your question. So notice that the trick for that one is iteration. Iteration turns out to be a critical component of this. That's right. You use flipped interaction when you want the LLM to drive the conversation in a very specific way to elicit appropriate context information for you to inject into the conversation. So it's all about getting more and better information into this context. Okay, in context learning. This one is fascinating, and I'll be talking about this one a little bit more later on. In context learning is providing examples in the context of a problem that need to be, oh, and I'm flipping back and forth. So are you seeing right now my in context learning?
No, we are not. We're just seeing the token embeddings and decoder stack.
Okay. All right. Let's see. All right. I'm going to return to the rest of those in just 1 minute. We'll continue that conversation. What I'd like for you to do now is to try out, we're going to go into the breakout rooms, and then I'm going to swap out my internet. So in your document, and I'll stop my share and then I'll restart and see if that will do it. In your document, you'll see that we have week 1, session 2. And the first one is breakouts, prompt engineering exploration. And what I would like you to do is to go ahead and from the paper, pick out the prompt patterns that you would like to try. So choose some of those and to try them out. So each person in the room, try their own, okay? Somebody share their screen. Be ready to talk about the things that you have. Go and put your room number underneath here. You'll go into the appropriate document. We're going to do this for 15 minutes. Umang, if we can go into the breakout rooms for 15 minutes. And when we come back, we're going to choose and ask for some interesting prompts that you have tried and how well they worked. I'll mention before you go in context learning, this is where you give examples of problems and their solutions. And then you give another problem and see if the model can solve it, having learned very quickly and very briefly on the examples that had been given. And I'll tell you why that's fascinating when we get back. Umang, go and feel free to move us into the breakout rooms whenever you're ready.
All right, here we go.
All right. Charo, I will make you host. And then what I'll do is I'm going to switch my Wi-Fi. Okay. and then you'll need to make me host again when I get back.
No
And
problem.
unless you go power mad and then,
No, I got you.
all right, you are host. And I'm going to switch to.
I think it just crashed on me, so.
Yep, let me just put you back in the room.
And Jesse, I think you might be muted.
I am. Okay, great. Would you mind making me host again? And then I will make you co-host.
I'm gonna try to make the right Jesse. Okay, see if this
The right Jesse is waving.
is that right.
Uh-oh, we've got a clone problem.
Yeah, there's two of you.
Yeah, there is, because I have my iPad going here as well.
Perfect. Okay. Did I make you host? Your desired host?
I will see if I am. Let's see if I can make you make host. Yes, you did. Thank you. I have the power. Okay, and were there any questions that were important that I should address when we come back that I didn't see?
There is a question in the Q&A.
Hello.
Yes, I sent them a response, but it would probably also be good for Jesse to see it as well.
Okay, in the QA.
Yeah, it's
Oh, it says answered. Okay, great. Are there any advantages to using encoder decoder architecture over?
Test out. So he sent out a paper for us to read about
I was kind of confused by what they meant.
Okay. Oh, does anybody need to be sent back to your? Does anybody need to be sent back to their room? That sounds like the worst parenting possible. Does someone need to be sent back to their room?
I think, yeah. Okay, yeah.
Okay, we're good. All right.
It's acting weird.
Okay. So Abby, my plan is that we'll go through these. We'll go through the prompt patterns a little bit more in depth, and then I'll do another breakout room. And when we end that one, Sharo, if you just want to take that one, that's going to be the programming one. And it's going to be like, and so it'd be really good to surface. I programmed it, it didn't work, it didn't run, or I programmed it, but it's using an old, library, all these different things that might come up, and then we'll use it as, okay, that's why you need to approach programming in a, structured manner. Yeah. And then you can either talk about that next week or this week, which is, and maybe this would be something to leave them with is, how do you know that it's right? Since you didn't write it, how do you know that it's right? And then just sort of lead them to the idea of testing. Yeah. Cool. All right. And how are things going so far? I'm sorry that it's been laggy, but has it been going all right?
Yeah, you haven't lagged for me at all, so I'm not
Okay.
entirely sure what's going on.
Okay.
Yeah, it's not been laggy for me either. So
Okay, good. And great questions. I mean, really, really good. And you see all the people there. I mean, Audrey's there, and I mean, we have a ton of folks that are. It's thrilling. Oh, and so tomorrow, you all have the invite now for the yeah. So we'll use whatever GPT-4 access we have, so we don't burn through everything. But and I'll set up actually, Miranda, if you wouldn't, actually, Umang, if you wouldn't mind setting up a Google Doc put it in an appropriate place in our, in our Google org place, just for us to be able to share everything that we've come up with and sort of put the document together.
Okay.
Do we also want a GitHub repo or no?
What I really want is I want to have, we still need to think about how to version. I think a repo would be good. I don't know if it's going to work as well for for how we're going to be using it. But I'd say let's have it, and then we'll be flexible and ready to go.
Okay, I'll go ahead and create one, and then if we don't
Okay.
use it, we don't use it.
Okay, fantastic. Bunch of faculty, man. Okay. Good. And Umang, I have not gotten the documents from John Shaw yet for the,
Okay.
I mean, so if we don't get them, how long would it take if we to encode them and get them up and available?
Almost instant,
Okay.
maybe a minute.
Okay.
What I was thinking was I was just gonna make a quick radio out of it, just so
Okay.
that they upload a file, it
Mhm.
encodes it, and we
Okay.
can put in a prompt and it'll work.
Yeah, but multiple files you can.
Uh-huh.
Okay. All right. And where's your memory store? Are you doing it in memory or doing it?
It was just like a deep lake, so just
Okay.
oh,
Okay. So, but the only concern that we'll have is if there's anything proprietary, but if it's a submitted grant, then it should be open.
Yeah.
Okay. If for some reason we don't get it at all, because I think Cliff was like putting it into what do they use? They use AWS. No, they use Databricks. So he's like putting something into Databricks, but that's not like. We'll have to look and we'll have to see.
okay. Yeah, I will be.
Okay.
I'll be there.
Welcome, Divya. Do you need to be put into a room?
Yeah, I was just trying to switch the room and
Oh.
I think it brought me back here. Sorry.
Okay. Can you see the rooms, or do you have a particular room you wanted to go to?
I'm able to see the rooms.
Okay.
Yeah, I think I'll go to some general one. Thank you.
I can only imagine sort of the trying to switch rooms and ending up here is like ending up in like the teacher's lounge. It's like, what? I don't want to be in here with you all. And 4 minutes feels like forever, but it's not for them. Welcome, Jeff.
Hi, can somebody move me back into breakout room 12, please? I had to readjust my settings.
Fantastic. Okay, great. And what I'm thinking and tell me what you all think about this, sort of setting different stations. If we have like if we only have like 3 people live with us, maybe we can just do it in our office.
Yeah.
Is it too many, you think? Because we could do it downstairs. If we do it downstairs, I almost want to bring some of the monitors down there. So, because otherwise it'll just be like, we could do laptop, and we'll have the large monitor, but it'd be good, the projector, it'd be nice to be able to collaborate a little bit more. I can check with John and see how many people he thinks will, I guess check with everybody and see how many can be in person. But so I was thinking of farming out the different sections of the grant, and then making sure that with the RFP, so we'll put the RFP part for that. This is what expected in this. Here's what it's going to be talked about, and then generate. But what we'll need to do is we'll need to have a really good statement of like the abstract or that first part of the grant, so they're all consistent. So we do that one first, sort of get that, and then do grant portion, RFP, that section for this grant, generate. Okay. And then I'm thinking, we're not going to, this is like, I'm pitching this as like this is your base level model. This is what you do if you don't have any, especially if you don't have the document store, right? So this is if you don't have a document store, if you don't have an auto GPT. I'm thinking the next generation for this is you have the document added as it is being written as your document store. So everything that you write is consistent. So you're over here writing this method section, but it looks up anything that it doesn't know about, and then maybe that's what we want to do with the document store, and just keep on refreshing it. If y'all wouldn't mind thinking about that.
Yeah.
It's okay if it's only partially successful. We don't want it to be a complete failure. So you want the base level model to be like good. And I think it can be, but that might make sense. If you all wouldn't mind, think about that. Do you want to have like all abstracts of grants that you've written, or do you want to have like the grant that you're writing? And I suppose if you have another grant that's really similar, then you can have that up. But what's striking me is like, as you're generating this, it's going to be inconsistent unless it's constantly referring to the other one. And maybe it's enough to have that in the prompt. All right, we're going to go back in. Welcome back, everybody. Welcome back. We'll give folks a chance to get here.
for some reason, after we came back from the breakout room, the chat history is gone,
Oh, that's interesting.
right? All the chat history is gone. I don't know if
Um,
everyone else experienced that.
Huh.
mean-
Let's see if I have it. Because we stayed in here. Yeah, so we still have it. So if there's anything in particular that you need, and of course, well, that'll be part of the. We do have the chat history. So if you need it for anything, let me know and we can make that available. We can just put
Yeah, I
it-
think the one question I see a couple of people ask is can you are you going to share that presentation?
Yes, definitely. I'll share the presentation and I'll share the document as well. I'll put a link to the presentation in the on
GitHub.
the yeah on GitHub. Yeah,
Okay, that'll be awesome.
absolutely. All right. Great. So let's go through, let's talk about let's go through first of all, before we go through all the different types, I'm going to ask you about all the different types and get examples from you. Did anyone have a really cool one that you would like to share? One that you were surprised with? Yes, Ivan. Up, and we cannot hear you, unfortunately, or at least I can't hear you.
Can you hear me?
Yes.
Okay, great. So basically the thing is that I asked him to ask something and he asked about the movie that I like. I said Pulp Fiction, and then I said like, what about the movie that he likes? And he's like, oh, I like this one, blah, blah, blah. And then I was like, okay, and what's the one that you don't like? And he was like, well, I can't share that information, it's too personal, I don't want to offend anybody. But he's like, but still there are some very bad movies, here's the list. I was like, okay, you are not gonna offend me, I'm not gonna tell anybody, so you can share. And in the end he said that he doesn't like Airbender.
Okay, so from this we know that the models have good taste. All right.
Yeah, exactly. It was super surprising, and therefore I have actually a question.
Yeah.
So why did he actually decide that the Last Airbender was like the most obvious answer for the kind of a movie that the thing shouldn't like?
So, when inferencing, there's a lot that goes into this, right? So you're getting those responses because that's part of the safety of the reinforcement learning from human feedback. And remember, it's not really an objective function, so you can't say, it is optimizing this. Instead, wholesale with reinforcement learning from human feedback, you went in and you twiddled with a bunch of the weights to make it act in a particular way. So at that point, what is it doing? What is it optimizing? It's unclear. That's why the models aren't calibrated. That means that the probabilities that you see in the models are no longer dependable. So you can't sort of get an idea of how sure it is of an answer, for example, anymore, because you've gone and you've changed those. So why Last Airbender? Unsure. Could be the whitewashing, could have been, it could have been, there's really no telling, but it is, we know it's at least related to the strength of response that it'd been trained on. So, so that may have been the most visceral responses, but it's hard to say. But that's great. But so you ran into, and you see what happens with the reinforcement learning from human feedback. This is why you do have some people who are saying, well, we just don't want that at all. You will absolutely run into problems. It's not just the safety and the helpfulness that's been trained in, it's also trying to address the bias that you have in there as well. And there's a real risk of not doing that, because then if you start building these, these models are going to be the foundations of many different solutions, right? They're going to be responding, they're going to be helping people make decisions. And if you have that unmitigated bias coming through, some people say, well, if that's what reality is, but it's not. Remember, this is a mirror of what we have written. And so this would be a way of propagating all the bias that we have, but in an unmitigated, raw way. And do we really want to build, the foundations of our society on that? Probably not. So very, very challenging. All right, so let's see, I think in chat we have another one here. You're a master.
I was playing around with it, and then you can just like, if you just ask it to generate a plausible full form of a certain abbreviation, just give it some random long string, and it will be like, I'm sorry, I cannot do this. But then give it a persona, like you're a master full form generator, right? And there's nothing that you can't not generate, and then all of a sudden it will give you like weird results. It will do it. So that's something really funny about it.
So you can ease, so you can see with the reinforcement for learning feedback, it's saying you do not respond, right? But if you do a persona, it's like, well, I'm not me anymore. So it's always going to be a bit of a cat and mouse game if you're trying to use it for safety. Fascinating though that it was able to do it if you told it, and that's the kind of stuff that you'll get with GPT-4. GPT 3.5, I don't think would be able to do that. That's a very sophisticated thing to do to generate that. Any others that people want to share before we dive into the particulars?
We just had a situation where we were asking it to give us restaurant recommendations, and it gave us the name of a restaurant where it also mentioned, it says Buchetto's Smiling Teeth and Yats. So it was almost like it was reading. There is a restaurant called Buchetto's or whatever it's called that has a logo of a smiling face.
Yes.
Like it was reading the image information as well.
Yes. That's fascinating. So absolutely. So GPT-4 is multimodal. And one of the things that it does do is it can take images and then interpret information in images. So apparently that was part of the training. It's not generally available because that inference is really expensive to do. So you can't generally put in your own image yet, but certainly that will be coming soon. And Raymond, did you have something?
Yes, I asked it to assume the persona of a data scientist and explain the steps to auto-generate functional connectivity matrices from resting state fMRI images.
Mm-hmm. Did it do a decent job?
It did actually a really good job. And I picked that question because that was part of a project that I did last fall. So I knew that I could have something compared to. But
so even on the deep ones, so even on the deep questions, it may have some good background. GPT-4 especially has deep knowledge in areas where you might not expect. That's great, Raymond.
Sorry.
That's Raymond. Let me go over to John. So John,
Yes,
did you have another one?
Yeah, I was civil engineer in my past life, so I've been having to try to design a bridge, and I just laugh because its last answer was, "Oh, I would recommend you consult a professional civil engineer." I had a lot of the persona issues where it would kind of lose that idea of being engineer, then would ask me questions, then would give me a lot of information.
Great. So there's a couple of really interesting things there. So first of all, and Stuart, I'm going to get to your comment there because that's a great comment as well. Context length matters. You only have about 4K. So it starts getting longer. It's going to forget that persona prompt at the very beginning. That is an overall problem with context length. Remember, context is expensive. You can't just have it go as long as you want. We're going to be talking about LangChain. LangChain is a way to augment tools to give them augment models to give them additional tools. Could be something as simple as give it a calculator. And so it can send its own prompt out to calculate numbers that you give it and then just put that directly back into the context so it can give you a good answer. This is what Bing does when it does a lookup on the internet. It will look up something on the web. It inserts that information back into the context and then runs its inference again. But the other thing that you can do with LangChain is that you can have the chat itself, that long chat, as a document that it looks up. And if you refer to the persona again or anything, it will look up what it should have known but has forgotten, and then put that back into the context. So that is one way to not increase the context length, but to increase the amount of information that you can sort of juggle at one time. You may not be able to remember everything, but based on the context, the current context that you have, the important parts of the previous conversation that you need to remember to bring back in. So think of this as sort of creating a loop where it can look up and remember where it was and then come back to it. Stuart, you picked up on the different types within the model. There's a creative mode. Creative mode can actually be really quite good, especially when you're using personas. It is a little bit unclear about exactly what creative mode is doing. I'm uncertain, but if somebody does know, I'm going to be, would love to talk to you during office hours. But creative mode seems to work a bit better for that. It might turn up the temperature a bit. It might reduce some of the restrictions. It's tough to know the actual differences between Bing GPT and GPT-4, but it does seem to work better when you're trying to do those. Let's go ahead and go through each of the persona types. I'm going to ask you for your experience with these. All right, so this is from the paper. Let's see. All right, so we have, did anybody try a meta language creation? Go ahead and put up your hand. And Umang, if I could ask for your help. If you could call someone out, because I can't see them on the screen right now. If somebody raises their hand, if you can call them out and ask them to speak. Yeah. Okay. Then let's go on to the next one. Meta language creation is helpful to give a very concise statement of what you need. So keep this one in mind because it's really quite powerful. This can be combined with in-context learning, where you describe what it is, and you might even give some examples of what it is, but it's a way to very concisely state what you want to do. Okay, let's go and go to the next one. Let's go ahead and get to the output automator. Did anyone try output automator? Okay, I don't think anybody tried
Hey,
that.
Jesse, in
Yes.
terms of output automator, you know, if we're talking about personas, absolutely, we tried personas. And
Oh yeah, and that'll be my next one. Absolutely, this is just a different kind of output automator.
oh, gotcha. Okay.
Yeah. So this one is really dead useful if you want to simplify moving the output into another format. So most powerfully, I use this when I am when I'm creating quizzes. So if you want to create low stake quizzes, or even, you know, if you just want to create quizzes and then you want to put them into Brightspace, what you can do is you can say, you know, format this, and this is between this and a template one, but you can say format this as a CSV that'd be appropriate for importing into Brightspace. Or you can use this to actually generate output as well. Now persona. So who tried, we talked to a couple of people shared persona. Raise your hand if you'd like to share a persona that you created. Omar, can you share a little bit about what you did and how successful it was?
So about a week ago, I had it simulate it being a chemist and having it describe a Fisher esterification. And it was successfully able to do that. So I tried it again this week. However, it did say that it can't simulate being a persona. And instead, but it still gave me the steps. And then this time it didn't give me the links when I asked for a source. And then another example was a week ago, I had it pretend that it was a psychometrician and asked for a raw score on a medical exam.
Yeah.
And it gave the wrong one. So then I asked the source for it, and it gives anecdotal evidence instead of a source. And then this week I go back and it doesn't want to give any links or any sources.
Yeah.
But it will describe the steps to get to topics.
And was this a GPT a 3.5 or was this Bing GPT?
This was ChatGPT.
Yeah. So here's another problem with when you have privately held models, especially ones that are constantly being modified. Remember how we talked about reinforcement learning from human feedback, and this is based on human feedback or a separate model trained on human feedback. So it learns what human preferences would be. It can't generate it, but it can say, oh, people prefer this response over to this response. They're constantly doing that, which means that all of those weights are constantly being moved to solve a different problem. So you may find, oh, you don't want to be able to refer to the grandmother and use the grandmother hack to have it do things for you. So then they do some additional training on it. But think about all the different parameters that are changing, then all of a sudden it's not able to answer something that it was able to answer before. Or it starts to get something wrong that it did not get wrong before. This is another critical reason why we really need to have good advancement in the open source models, even if they're not as powerful, right? Because the stuff that you need to have repeatable, replicable, you want to do with those models. Then only use these larger models if you need to have additional judgment or additional cognitive abilities that are not present in the smaller models. So this is why it's really important to understand LangChain, how to pull these things together, because you can't just, you just can't have something that is constantly shifting on your feet. You can't have it for business where it works one week and then, hey, the next week it doesn't work. Why? Because the model changed. You can't have it in scientific research because you can't replicate, because now the model's changed and there's no way to version the model. That will not do. So one of the things we're going to be emphasizing and working on, certainly at the DSI, on part of everyone at the university, is to make these open source models available to everyone. All right. I had a couple of other hands up. Someone else want to share their persona? Oh, and then John in the chat, I'm gonna mention something. Let me mention this from John's. It had a lot of trouble with critical thinking, like design a bridge similar to Korean veterans. I'm going to mention another type of prompt, which is called chain of thought. This is not explicit in the paper. It's in a couple of different places, but chain of thought requests the model to explicitly state how it is getting at each part. It turns out that with difficult problems, just like with humans, if you ask them to think out loud, use a scratch pad, they stop trying to make the leap directly from problem statement to solution. Instead, they do a step-by-step approach, which tends to be much more robust and be able to solve much more complex problems. And you can diagnose what's happening with the chain of thought. So when you have advanced problems or tricky problems or anything that involves, multiple steps or anything that is big that can be broken down, chain of thought is often an excellent way to get the model to slow down. It actually forces the model to give you more compute because it's generating more tokens, and it has to predict what the small parts of this step is before it goes on to the next part. So you're literally forcing it to do more inferencing, which is more compute, which is more capability in solving problems. Any questions about chain of thought before we go back to persona?
How do you prompt it to do a chain of thought?
Okay, so do you all see the chain of thought right here on my screen? Nope. Okay, I'm going to stop my share and restart my share. One moment. So this is one way of doing it. You quite literally say use chain of thought, or you can describe chain of thought. You can say describe step by step how you would. And I can't tell you exactly because it depends on the model, right? So what particular prompt might work better is going to depend on the model. So we can get in the neighborhood of this, and then you have to iterate. One thing that I'll point out, though, is as you're iterating, you notice down here where it says prompt refinement. This is another critical step, especially if you want to be able to quickly reinstate and quickly redo everything you've done, which is ask the model itself to restate everything that you've given it in a single shorter prompt that will produce the same quality output. And what it will do is, as far as its context goes back, it'll go back, pull everything that it has, pull it into a single, again, shorter prompt, which should sort of immediately get you there. So you almost like always have to iterate a little bit. This pulls it all together into a single prompt. These kinds of things, chain of thought, prompt refinement, tend to work better with more advanced models like GPT-4. They can work in GPT 3.5, but they tend to work better in GPT-4. Any questions about chain of thought or prompt refinement?
Hi, quick question about prompt refinement. Are we still running up against the 4,000 token limitation, right? In terms of recollection? Yeah.
You are, which is one of the reasons why you might want to do refinement, right? Because if you burned through like 1,000 tokens describing what you want, then it's worthwhile to say, you might be able to get it down to maybe 500 tokens, or 200 tokens. You might be able to get much shorter, but you do run into the problem where if it's already past your token length, then if you've already passed your context length, you're kind of in trouble. You're gonna have a way around that by the end of next week, though, because you'll understand how to build a memory for your chats. So that's something that you can do. If you need something that's really long, instead of using the raw interface directly to the chat model, instead what you'll do is you'll actually build yourself, and absolutely you'll be able to build yourself by the end of the 3rd week, an interface so it'll remember and bring back into memory that part that it needs to have. It'll leave out all the other stuff that it gave you. If you ask it to restate the prompts that you have given, it'll pull them all into memory and be able to do that refinement for you. Other questions? All right, then let's go through.
We do have a hand raised.
Oh, thank you. Yes, go ahead.
So I was wondering, when we do a more condensing of the prompt by asking it to create it into a shorter output, would it give the same output if I feed it to a completely new chat with no context at all?
You will have to try. I mean, right? That is one of the reasons why you can do the refinement. If you do the refinement, you can also say such that I can give only the prompt and then you will be able to produce the same output, right? Then the idea is that, yes, you ought to be able to move that over to a clean session and to restart. Let's go and go. We'll finish up conversation around the different prompts. We'll spend a little bit of time next week talking about it. What I'd like to do now is to open up another breakout room. So you'll see the second prompt there for the breakout room concerns programming. You'll notice we haven't actually talked about programming at all, but this is kind of the point. The idea is for you to try to write a program given just what you know now. Describe it however you think it's going to be. I'm interested in what you try, whether it works, what doesn't work. So be sure to record in your breakout rooms what worked, what didn't work. Dr. Bell is going to be talking to you all when you return and getting your feedback on what worked and didn't work. You can think of this as, yes, a preview of what we're going to be doing next week. And not so subtle hint, we're not going to be doing it willy-nilly. So go experiment. Let's see what you can do. Then at the end of the session today, Dr. Pecciolante is going to be talking about other types of generative models that may be of interest. All right, Dr. Bell, I'm going to make you the host, and I will see you all next week. So you all continue. I'll see you next week. Bye.
All right, so I think we're set to open up the breakout rooms. And then okay, and in 15 minutes, we'll come back and discuss.
Some of you aren't assigned, so I'm gonna assign you to a breakout room now.
Do we just wait for you to put us in?
Yeah, or sure, if there's a particular room that you'd like to join, you can also join that.
I think it was sometime last.
And does anyone else need help getting into their breakout room? We can put you in one. I see that someone in breakout room 19 asked for help. Would one of you all be able to go into room 19 to help?
I can go. Where do you see that? How do you see that they asked for help?
I just got a pop up.
It just told you.
Yeah.
The thing that Bing can
All right. Okay. I will see what they need.
with GPT-4 is also web search.
Matthew, are you having trouble joining a room? I think I assigned you to one, but we still see you here.
No, I'm not having trouble. I'm just working in the background. And so I left the room so that I can concentrate, really.
Okay. Sure. I had a thought about why Bing is struggling with personas, and I was thinking it's because it's already given a persona because it's not RLHF, it already has one. And so when it's not in creative mode, when I guess it's in precise mode, its persona is really strict about all the rules. And when it's in sort of a creative mode, it perhaps the persona changes a little bit to allow for it to deviate from its preset rules.
Interesting. Yeah, I could see it. So even last night, I was trying to use Bing for some random verification of some TikTok video that I saw. It was talking about deer and then how their communication structure. And I was like, that sounds right. Let's see that publication. And I used Bing GPT, but see, I feel like I did use a persona yesterday. But I think you're right. I used that persona in creative mode, but it didn't help it. And then I had to go to precise mode and it gave me a paper that I used the references in to find the paper that I was looking for. But actually I never actually found, but that's okay. So I think you're right. That sounds right. That would make a lot of sense. Also, I feel like Bing is not producing you remember when we first were using Bing and it was like, it would do like multiple searches,
Mm-hmm.
that it would give a response? I feel like is it doing that? Like, have you observed it doing that, or does it tend to really just one search?
I really don't use Bing because I've never liked it. Also, the fact that they make me use Microsoft Edge, like I just use GPT-4.
Yeah.
So I don't know as much, but yeah, I remember it used to do a bunch of searches for everything. So if it stopped doing that, something must have changed.
Do you have the plugin on GPT-4 for like web search?
Nope.
I only use
But I have found ways that I can use LangChain to do it. I haven't tried it, but I will be over this weekend trying to see how I can use the Google Search API wrapper along with GPT 3.5, I guess, because I still don't have 4 API, and see how far that gets me.
Yeah, Bing GPT, I only use it when I'm trying to search the internet and I can't get Google to cooperate. And then I just end up going back and forth. Yes.
Can you ask you a question? What's the difference between GPT and Bing GPT?
I think that is a good question. And I think it's a proprietary sort of question. So there's GPT-4. So, okay, so there's ChatGPT, which is GPT 3.5, which would be a different version than GPT-4. And then Bing GPT is based on GPT-4, but it has some differences that Microsoft, I don't know that they have released the details on for integrations with Bing.
But generally, this is two different platforms from two different companies, right?
Well, GPT-4 is coming from OpenAI, just period.
Yeah.
Then Bing GPT was the same GPT-4 with some different sort of manipulations done by Microsoft.
But they use GPT-4.
Like the GPT-4 from OpenAI.
Mm-hmm. Okay.
So far as we know, so far as has been reported.
But in addition to these two, GPT-4 and Bing GPT, any other widely available software for any user to use except these two?
So I think that they're quite like that are publicly accessible, and for sure Umang and oh, she's not in here, but Umang and Miranda can comment on this. But there's things like Bard, and if you use a platform called Poe, it gives like a lot of access to different types of models. There's also a number of open source models that have been released, and so there's like Hugging Chat or something like that. So there's some that are offered directly through and by Hugging Face, but are they as performant as GPT-4? Not sure. But there are just a number of models that are available, and there's been some new ones that have been recently released from being trained, and they're open source.
Yeah, I would say sorry, go ahead.
There is no any, how to say, list what's available.
Yeah, I would say the closest alternative to something that's free and open, not open source, but widely available would be Google's Bard. You just need to sign up for a wait list, and you usually get access pretty quickly. It performs fairly well, but it's definitely not as good as GPT-4 from what I've seen. Poe does have, so Poe is an app that you can download, but it has access to a couple of different models, including GPT-4 and ChatGPT. They have a model called Claude, and they just released Claude Plus, which is available with a subscription. That is actually pretty good. I haven't tested it out extensively, but I've been getting very similar results along the lines of Google Bard and GPT 3.5. So that is also a good alternative. And then I think Meta released Llama. Was it Meta? Llama is also another open source alternative, but I've not played around with that.
But currently there is no any specialized AI, let's say in engineering or physics or biology or whatever, medicine or That because everything depends of the database they use. I mean, the information they supply.
Yeah, no, I don't think
Oh,
so, sure.
I was just gonna say it depends on exactly what you mean by that. Because although there are things like ChatGPTs and GPT-4, as Jesse was saying, that's like a particular architecture of a particular like size. There are other similar, there are other types of transformer models that have been trained on different types of data. And it just so happens that usually they're a lot smaller. And some of those will be available on Hugging Face. Now, in the areas that you described, they might be a little light. But I will say at Vanderbilt, we're working on lots of models that are transformer models, not the size currently of your GPT-4s and ChatGPTs, but smaller transformer models that are more tailored to any particular discipline as opposed to like this wide arching decoder model.
But is it possible to, how to say, force GPT-4, for example, to look at particular database that is available open?
I think Umang is a great person to answer this question.
Yeah, so GPT-4 itself, if it was trained on that data, it might already know about it. But in the scenario that it isn't, which is likely, the best alternative would be to use LangChain, which is essentially a framework that allows you to use these models alongside other technologies, so you can actually provide it a whole database or a document in its memory, and it can work off of that. And we'll be talking about that in more detail next week.
But this means there is a way to kind of connect on your request to GPT-4, connect GPT to particular database that you have access.
Yes, for that you will need access to the OpenAI API. It is available for free for GPT 3.5 Turbo. And I think for GPT-4, you will be on a wait list. I've been on a wait list for about 2 months now, and I still haven't heard anything. So it really depends on when you get access to the GPT-4 API. But yes, there is a way. It's just a matter of time till everyone has access to that.
And also there's something to be said about the length of exactly the documents that you need. So if you have like, I don't know, 5 documents that you want to use like very specifically to answer these questions, you may be able to put them into something like GPT-4, which has a longer window of text that it can look at.
Yeah, but for 5 documents, probably you can do the job yourself, right? If it is 5,000 or 5 million, it's a different story. But 5 documents, it's relatively easy.
I mean, I think that would be 5 big documents because I think the context length is 24,000 tokens. And so I think that's like, I think that's sizable. I don't know, it can be pretty nice though, especially if you have sets of 5 documents. So for example, in one of our projects, we have these legal files. And so like it's a legal case. And so each case has a bunch of files in it. So it would be helpful for us to be able to put all of those files in for like the 3,000 cases that we have, and then just iterate through that.
But from pure practical point of view, how actually you connect step by step, let's say GPT-4 to particular data set? What you need to do, just with few sentences.
Yeah, so that would be using LangChain. So LangChain, as I said, it's a framework. So they make it very easy to do things like this. They'll have, you can set up a document store, and then you can connect that document store to either like a local system. Essentially, you tell it where the documents are, it'll encode them and embed them. It'll get all the embeddings from it, and then you can set up some sort of a retriever that will grab only the relevant documents from it. So it'll do a semantic search based off of the prompt that you've asked. It'll read through all the documents that you have. It'll pick the ones that are relevant. It'll put that into the context, and GPT-4 or 3.5 in this case will be able to reference that and answer questions off of that, or do whatever you need to with it. They provide a lot of different applications. LangChain is really, really extensive. So there's a lot of possibilities there. So, and we'll talk about some of those in detail, but their documentation is great. And so you can definitely go check that out. And
But the idea is that you relatively easily can learn how to do it.
yes, it's very easy.
All right, awesome. Welcome back, folks. Welcome back. It's great to see you back in the main room. And I am excited to hear more about your endeavors with programming. If you know me, you know that I love programming. So this is something I'm excited to talk about. All right, so maybe we'll go through, let's see, make sure Abby has enough time. We're here at about 10:30. Maybe we'll have maybe 2 or 3 people who might have had some very interesting experiences in terms of the programming. Describe their experiences. So if you want to just raise your hand, like through the reactions pane, I will be happy to call on you. Oh, lots of raised hands. Let's start with Isaac.
Hi, can you hear me?
Yes.
Yeah, so I was trying to use Python. I don't know, it's just having fun. I knew that there's a Pokemon API, so I was like, I asked Bing to generate some code to randomly pull a photo down and then display it. But it kept running into some issues with the PIL library trying to show the image. And when I tried to ask it clarifying questions, it seemed like it had a tendency to do a web search, take whatever it found from the web search and give me that as a suggestion, but then kind of forget the code that it had already given me, so it wouldn't update it or fix it. And then when I switched to GPT-4 on OpenAI, it seemed to fix it right away. I gave it the code, gave it the error, and it was able to straighten it out. And then also was able to translate it into another language.
Oh, amazing. Were you able to see, like, were you able to try in something like Google Colab or something if the code actually ran?
Yes, I did. And I got a picture of a little Rattata, which is fun. So
That's awesome. That's great to hear. I'm glad that worked for you. Let's see, Roberto.
Yeah, I was trying to get the, what do you call it, ChatGPT to be able to find when a function crossed over to the y-axis. And I thought it was going to do something like a bisection method or a Newton method, maybe even like a secant one. What it did was more of brute force, did every single individual plot given a certain like length. And then where it hit 0, it then gave that output instead of trying to like find like a easier mathematical method.
Interesting. And so it wrote the code to be able to do this?
Yeah, I tried it out in Jupyter Notebook. It initially gave one for like a linear formula, but then I restructured the phrasing so it'd be quadratic and it worked fine.
Wow, that's really interesting. I mean, I'm glad that works. Sometimes they do give answers that are, they're a little old in the API. And so they produce some errors, but no, that's great. I love that you were able to iterate, especially with your questioning, to get the answer that you wanted. It's perfect. Let's hear from Jordan.
Hey, so I wanted to ask Bing GPT to like help me come up with a visualization of graphs showing like time series decomposition. And I asked, when I prompted Bing to do this, Bing was like, I am not an expert in visualization. I'm a language model, but I can offer you like example resources, and it pointed to links of like articles about time series decomposition. But when I asked the same question to ChatGPT, or it generated the Python code to do that, which I thought was kind of interesting.
Was the Python code able to run successfully? Do you have a chance to try it?
Yes. Yeah.
Oh, that's fantastic. So it's generating these visualizations. That's awesome. Are they, would you say that they're good visualizations, or are they just like visualizations?
I would say it's good, but it's like your typical, it kind of is like your typical graph of what you would see for time series decomposition.
Okay, gotcha. No, that sounds awesome. Maybe I don't want to take too much time from Abby, but maybe we'll do two last questions. Omar, or answers. Omar.
So for the programming, I asked both ChatGPT and Bing GPT to make a program of a character running from left and right using controls. for the Unity game engine. So for both of them, without specifying the piece of code needed to get the left and right arrow key or the A and D arrow keys working, it would give me the physics for it and exactly how to do it, but it would not give me the controls, even when I specified for it. But when I went to the internet and asked for the exact piece of code that is needed, or the if statement needed, and then gave it to Bing GPT and ChatGPT and called them out on it, it fixed the code and now it works.
That's interesting. I love the intuition across all of you to, I don't know, ask it more or give it more information to refine its answers. I think that's a great way of approaching programming with AI as a pair. Let's see, Audrey.
Yeah, my example seems a little bit more rudimentary, but basically I asked Bing to help me write some code to check a list of data in Google Sheets to confirm that each row starts with a verb. This is essentially how I have my students like update and keep track of like their to-do list essentially. And so it was able to write the code to look through the Google Apps script, and it initially had like a rudimentary is verb like check function that it wrote, where it pre-populated it with a list of common verbs that a sentence could start with. But when I told it that it's not possible to encode directly all the verbs that I needed to check for, and I asked it to could it modify the code so that the code could call ChatGPT or Bing to do the checking of whether the sentence starts with a verb. And so then it gave me new code that could call ChatGPT or Bing from the Google Apps script so that I could have a more robust function. So
That is really amazing. So it works to write the Google script itself, the Google Apps
yeah,
script?
so it wrote wrote the code for the Google Apps script, and then it incorporated into it calling functions that would allow me to call ChatGPT or Bing so that it can have access to more information for processing the text. And
That's absolutely fantastic. Wow, it's great. Y'all are really great at being able to interact with the generative AI. Some people just ask it a question directly, and if they don't get the answer they like, they're just like, oh, well, this doesn't work. But so I see we have a few more hands up. Let me see, Abby, what are your thoughts? I know you wanted to talk about stable diffusion.
Oh, we can take time for a few more comments.
Okay, that sounds great. John?
Yeah, I was just working right now and I asked the Bing chat to give me some prompt engineering prompts. And then basically it gave me some coding prompts for R. I pulled one of those, like copy and pasted it back in. That gave me the R Studio code for it.
So did your R code work?
Yeah, no, it worked. I just tested it right now. I know in our breakout room, we did a code like with Python at first and then asked it like, can you translate it to R? And it did that as well.
Nice. And can you just speak briefly about the complexity of this code that you asked, or the task that you asked it to write the code for?
I mean, it wasn't a super complex code. It was just like a list of numbers and returning sums of the even numbers.
Oh, nice. Nice. That sounds really great. And I love that you and someone else asked it to translate to another language, and both of these are working. I think it comes back to what Jesse was saying earlier about being sort of multilingual, these models, because I mean, Python and R, this is going to be a multilingual situation as well. Jennifer.
I was just working through, I had an example where I was trying to have it give me a Python code for finding a place to rent within a specific zip code and price range. So it generated the code in Python. And the code found an API that exists on the web. I didn't get to check it to see if it was free or you have to pay for it. And then I put it in Collab. It took the inputs, like the price range and the zip code, but it didn't generate the output because of a JavaScript or a collab error. So I was wondering if anybody ran into that. Otherwise, it's the API and I have to figure out what's wrong with the code, but it at least, I was surprised that it actually found an API that I could use to try to help me execute. So that was interesting.
Wow, that is really interesting. Is it a real API or is it just something that's sort of?
Yeah, it exists. I just need to check to see if it's free. If it's free and public, then it can generate the output. But if it's not, then there's a paywall. So there you go.
Wow, that's really impressive. I love that it was able to leverage its training data to be able to find an API that was an existing API. No, I think that's really awesome. And I love the way that you've tried to verify that, but also seeing that there are some errors that it sometimes generates depending on the actual coding environment in which you choose to run things. So that's really interesting. A last piece of something that I'll convey about this before we wrap up is it's always exciting when code just runs. Like, you know, I remember when I used to code in C++, like if it compiled, that was just the best. But there sometimes is this distinction between something that's able to run and something that actually does the task that you want it to do. And a way to approach that with generative AI is through the usage of tests. So even if your code is running, maybe it's doing a group by incorrectly, or maybe it's assessing maybe a wrong column or something. We should write tests to make sure that the code that we're generating is actually doing the thing that we want it to do. And we'll be talking more about AI assisted programming next week. And you'll be talking a lot with me because I love programming. All right. And with that, I'll pass it off to Abby.
Okay, hi. So I'm Abby Petulante. I'm a postdoc at the DSI, and I'm gonna just talk to you pretty briefly, pretty high level about a different kind of type of generative model, which is diffusion models, which you've probably heard of, like DALL-E or Midjourney or Stable Diffusion, or all of this kind of class of models that the main goal is to take text and transform it into images. So let me share my screen real quick. Okay, can everybody see this? Cool.
Yeah.
Okay, so this is just one example that I'll start with of one of these kind of online web applications for interacting with these models. Many of these exist. I do believe that this one is paid after you generate some certain number of free images, which I think is the kind of model that a lot of these are going with right now, but you can at least kind of play around for a little bit. And basically, they're very simple, at least in the kind of web app way of interacting with them, where you enter some sort of prompt, and this one in particular will kind of give you example prompts, and you can kind of see something that you like. So this sounds kind of fun, and generate, as you can see from just a couple lines of text, some images that, you know, quite closely match the text that you put in. And so we can come back to this in a few minutes and kind of talk exactly about sort of the best ways to sort of construct these prompts in order to get images that you might want, and also talk about this negative prompt column that I sort of glossed over for the moment. But I'm going to kind of start with just a really kind of like very quick overview of diffusion models and kind of how they work. This will be sort of, yeah, at kind of a very high level and quick overview, but there's lots of resources out there that kind of go a little bit more in depth into it, but this will kind of help understand what is going on here. So basically, diffusion models are entirely built on a concept of denoising. And basically the idea behind denoising is that if you are able to train a model to remove noise that was added to an image. So if you start with an image and you add random noise to it, and a model is able to successfully remove that noise from the image in order to get back out what the real image was, that same denoising procedure can actually construct an image out of pure noise. So a model that can accurately remove added noise can also just remove from an image that was entirely noise to begin with, enough of that random information to construct an image starting from noise, which is a very kind of cool idea, at least I think. And so you carve out these ideas or these images from an initial picture of just noise. Okay, so skipping right into this concept of latent diffusion, because I think a lot of the major models today are using latent diffusion. This example that I just showed you, which is a really kind of simple example, I'm showing you the entire image here. So you're removing noise from a full resolution image. But it was kind of discovered that you actually could do this entirely in the latent space of an image. So if you take an initial image and you crunch it down into some smaller latent representation, lower dimensional representation of the image, it actually works to do the denoising on that perfectly fine. And that was kind of a big breakthrough in these types of models that made them much more efficient, because the latent space of an image is way, way, way smaller than like the literal pixel space of an image. And so that made sort of doing this type of generation, because images are quite large and it was otherwise quite tough, something that was possible to do very quickly and very efficiently. And so a lot of what I'm taking is coming from this Hugging Face blog. A lot of the images that I'm going to show you, this Hugging Face and in general, I love Hugging Face. They have so many great resources. And this particular blog about stable diffusion kind of really nicely goes through the steps. So it's a great resource if you want to read a little bit more in depth about this. So I did not mean to scroll. Okay, so the latent diffusion model has three main components, which we're going to just touch on kind of briefly. The first kind of concept in these models is a variational autoencoder, which is this model whose entire goal is basically to take an image, turn it down into a compressed representation, and then reconstruct that image. So there's an encoder and a decoder part, and the entire goal of this, sort of model in and of itself is to take a starting image, compress it down, and then learn to reconstruct that same image. So this is basically just learning how to accurately represent an image in the latent space and how to accurately reconstruct an image from a latent space representation. So this is kind of key to our ability to work in the latent space, or the ability of a diffusion model to work in the latent space, is that this component of the model works really well. The next kind of fundamental component, and a lot kind of goes on here that I am going to gloss over a little bit, but the next kind of fundamental component of a diffusion model is a UNet. A UNet is a convolutional neural network. So kind of these existed long before this sort of new technology of transformers. And the whole goal of a UNet is to transform an image into some other image. And typically in a generation task, that's your image of noise into a image of not noise, an image that has structure. So within, a stable diffusion model or any latent diffusion model, this is going to be taking a image of noise in the latent space and turning that into an image of things you'd really want, real structure, but also in the latent space. And the UNet is the portion of this model that is doing that denoising that we talked about. So over kind of multiple steps, it's using that training to denoise to transform this image into something that has meaningful structure in it. And then the final thing is that even though I kind of started this whole thing with saying that we're going from text into images, I have not talked about the text component yet. So obviously any model that is going to input text has to have some sort of text embedding, so that you want to turn that text into sort of meaningful information about what those words and what that text means. That is happening via some sort of text encoder that will also be used to transform the text into embeddings that can be given into the UNet. So the UNet will get the information about the text that you want and some sort of latent noise image and construct that into a final image. So this is kind of the pipeline that puts it all together, where basically the user starts by typing in a prompt, which then some text transformer encodes. So we talked today about, encoders and decoders. In this, we just want the encoder. So you turn the text into an embedding about the text. Then you have some sort of latent noise image, which, we talked about the VAE, the variational autoencoder, has learned how to turn a latent image back into a real image. So now we just can give an image of noise that would exist in the latent space. So a smaller, compressed compared to the final output image that we want. So you see this has 64 by 64 here. That's much compressed compared to 512 by 512. So you can begin with a 64 by 64 image of noise, which is noise in the latent space. Those two things are fed to the UNet, and the UNet over many steps is going to denoise that latent space image conditioned on the text that you gave it, which has now been embedded into a way that the UNet can understand. And over many steps, the UNet will generate for you a 64 by 64, in this case, image representation of the final image within the latent space. And then we just need the decoder from the VAE. So remember, over here, the VAE both learns how to turn an image into latent space, but also learns how to turn a latent space image back into the same image that you started with. So now we're going to make use of just that decoder of the VAE in order to turn that latent space image back out into a real image. And so that's kind of the basic, like I said, high level idea about how these latent diffusion models are working and how we're able to go from text and really add text just to kind of random noise and get out an image that looks really good by the end of it. So a lot of what we've been talking about, and so we'll touch a little bit more on it, is prompting. So prompting of diffusion models is kind of like we've sort of touched on prompting of, these chat models. It's also just a bit of an art form. There's a bit of kind of tweaking and kind of thinking about what you really want the model to give you and specificity that you need to have in order to get kind of the best results. So we can kind of play around with a little bit of that prompting and talk about what sort of prompt engineering for these types of models might look like. Okay, so we can start with, I'm going to start with like a different random one. Okay, so for instance, this prompt, there's a few things to notice kind of with all of these random prompts that I generate, which is that they usually start with kind of some basic description of what you want the image to be, and then kind of move into these highly descriptive I don't know, qualifiers almost after. So between every comma, this is like a new thought or a new kind of, yeah, I guess thought that you want to give the model, a new specific idea that the model is getting about this image. So oftentimes you'll start with something like a vast desert with sand dunes and a lone oasis in the distance. So kind of this high level description of the image. But then you can add to that after lots of kind of specific words. So a hot sun and clear blue sky will help kind of hammer in on the background that you want the image to have. You can put in these types of words, even though these aren't sort of descriptive of the image itself, but these are very helpful because obviously the text embedding model does still kind of understand what things that are peaceful and serene kind of mean. So you put in kind of words like that to also help drive sort of, the feel of the image. There's lots of these kind of very utility things that people use, like high resolution, 4K. If you're putting in a picture of food, you might say like food photography, things like that are sort of going to drive, specifically the way that the image is going to look. And in the negative prompt is basically about saying what things you want the model to move away from. So you're able to put in both a positive prompt and a negative prompt into all of these models, where the prompt says what you want it to look like, and the negative prompt obviously was what you don't want it to look like. So a lot of times if you put in certain words and you find that the model just really wants to like generate a particular thing along with those words, because things just tend to go together, you can put into the negative prompt that thing that it keeps wanting to add, because it's kind of clunky to like say not something into the positive prompt. So a good example is before I was trying to generate images of chocolate cake. That was one of the kind of random prompts that it gave me. And in all the images of chocolate cake, until I specified there would be like a dollop of whipped cream on the chocolate cake. But if I wanted an image of like pure chocolate decadence, then I didn't want any like vanilla, vanilla cream or whipped cream in the picture. So that's the type of thing that you might put in a negative prompt, right? It's hard to specify in a positive prompt to like not put whipped cream, but you might specify in the negative prompt that like, I don't want whipped cream. And yeah, the other thing about prompting is that for these types of models is that the earlier that you put something into a prompt, kind of the more attention is given to it in the model. So if you sort of find that some of the things that you're putting in the positive prompt are not seeming to actually end up in the image, you can always change your order of sort of these things that you're, putting behind commas. So if I like really wanted, I don't know, like a small pond or water feature or something, this might just put it in. But usually if your prompt gets really, really long and something is all the way at the end like that, it might not include it every time. And so there's also a little bit of ordering. Yeah, so there's no like small pond or water feature here. But if we were to try to, if we were to try to stick it up here, and it does take a second to generate, although very fast compared to other things. Okay, well, it doesn't want to give me, I guess I said the feature was in the distance, maybe. This is live prompt engineering. And yeah, I mean, this is kind of where the idea that you have to sort of mess with it a lot comes from, because a lot of times it is that you just have to really get kind of the right feature. The other thing is that all of these image models, if you do want to play around with them, they usually give you the option to generate like a lot of images at once. And that really is kind of for this very reason, that very, very rarely are you happy and do you get what you want out of like the first image generation. And so all of these models, I think, are kind of aware of that and give you the option to generate like 20 images at once. And odds are like one of those looks how you want it to look. So yeah. But okay, we are almost out of time. So that is all that I will talk about so that we can move into the office hours for people who have to go. But that's a basic introduction to diffusion models. And also, yeah, this is a really cool tool if you want to just play around with some images yourself, see what you can generate. Okay.
All right, fantastic. Thank you so much, Abby. And so as Abby said, we're at the end of our time now, but we will see you again on Monday. Enjoy graduation on Friday, I think. But otherwise we'll be here for the next hour for office hours. So please feel free to stick around if you have any questions. Otherwise, we'll see you on Monday. Bye.
Just make sure I understood. So is there no session on Friday then?
No session on Friday.
Okay, I must have missed that at some point for now. Thank you.
No problem. All right, looks like Matt has a question. Matthew has a question.
Yeah, thank you. I was curious to know if you can, just in response to the diffusion, stable diffusion and Dream Studio, do you think it would be possible, or I don't know if others have tried this before, to use the same technique, to use the same approach to simply or increase the signal to noise ratio on an existing image? So like there's an example that I'm sort of familiar with is, imagine you're trying to track a protein, a fluorescent protein in a biological organism. You know, a lot of times those images are very, very noisy. Is it possible to decrease that noise, but not create artifacts in the image, so that you're sort of still remaining true to what's going on biologically? Does that question make sense?
Yes. That is a very good question. I think, okay, well, so I'm a little bit speculating. I think that if you were to do something like that, in order to not get those artifacts, you would rather just work in like the pixel space. But I do think you might still, I think that there still can be artifact problems in the pixel space, but I think that that is less than when you work in that latent space. But I think that, you know, lots of models exist kind of without the, you know, like the full diffusion pipeline is really focusing on the generation of sort of stuff out of noise. But I do, like, models do certainly exist with kind of like standard CNN techniques to, like, for instance, super resolve images. So like adding back, you know, true information back into the image and stuff like that. So it might just be possible with just kind of that UNet denoising portion without kind of those other components of a full stable diffusion model, which is more focused on sort of making up stuff based on the text and all that. But I don't, like, off the top of my head know of something that exactly does that.
Well, I was going to chime in for a second. So I know that several of the microscope software companies, their proprietary software like NIS Elements has an AI noise removal program already built in. And so it does exactly this, right? It is made for taking noise out of fluorescent images.
Other questions? just interested in hearing everybody else's questions. I know, I get it. Yes, I'm gonna butcher this one. Name starts with a D.
About it. It's Devere.
Devere.
It's English, so I get it a lot. So my question is also about the diffusion models. With my experience trying to work with them when trying to generate images that are more precise or have precise lines or have words in them, like written words, then the models perform a lot worse. Is there a specific reason for that?
Yeah, so the models, yeah, in general cannot make text. If you want like precise lines, I think a lot of times like qualifiers, like some people even found that putting in like the specific camera, because specific cameras have like certain styles. So if you specify you want like a Canon 4K HD, like I think that helps kind of improve like the resolution and the quality of the image. But yeah, the models in general are unable to make text. And I think it just stems from the fact that like the text, there is never right now anyway, a part of the model that understands the text in the images that the model's trained on to like be text, the way that like the text you input into the model is text. I don't know if anyone's working on that, if it would be possible to like somehow, pick out what text looks like in images based on like something, but right now the models don't have that. So if you like want, a billboard that says like oranges on it, there isn't a way for the portion of the model that was actually trained on images to understand what writing that says oranges on it actually looks like. It does, I think, understand what like writing looks like, but not what specific word, like how to recreate specific words. And so it's a bit of just a thing that is kind of impossible right now. The only thing I can think that could get you close is that there was a model that came out actually fairly recently called ControlNet, which was like a version of Stable Diffusion that was additionally conditioned on some sort of input that you give it. And so that is able to work by like, if you give it like a feature map, for instance, it'll like fill it in, or if you give it like a little drawing, it'll like condition on the little drawing you give it in order to like generate something that looks like the initial image you give it. I don't know, but I think that it would be true that if you were to like write text with that, like into an image and then give that into ControlNet, that text would be preserved, not again because the model understands it as text, but because it in ControlNet, it very specifically will not remove what you have given it in the initial image. So I think if you wanted to generate text right now in images, like that would be the way to do it.
Other questions?
So like, if you wanted to produce like a logo for like a company, or you wanted to like, cause you can, I guess you can tell it like how to, for example, like for Dream Studio, you could use it for like computer graphics type stuff that's like specifically for a company. I mean, I think this is where people are kind of concerned, because it kind of goes into maybe like their, computer graphics artists, like kind of space, but you can actually go in and do that. And then what is the use for these things? Like, I mean, like the copyright and all that. I mean, I know this gets out of like the technology space, but like more into the policy space. Like, if you use some of these tools to generate content, whether it's text or otherwise, like, is there a common set of rules or regulations or policies that kind of deal like with how to deal with these pictures? I mean, do you own them because you created them with the text, or are they owned by the company that did the AI model, or is that like a concern that people have in the future for using these kinds of models?
That's a great question that I don't actually know the answer to. I don't know if somebody else knows the answer to. It's my understanding that if you make an image with them, you kind of own, like right now, you just kind of own that image and you can do whatever you want with it. But yeah, I don't actually know too much about the details. I don't know.
So I believe there was a regulation that said that it can't be copyrighted, right?
Yeah, like you can't copyright yourself
Yeah.
you make with. Yeah.
Yeah, you can't like copyright the images or content generated. But I mean, yeah, it's a huge issue that people are worried about. And you have artists on all of the major like art post websites where they're having issues with this because they put their art on there and that's what the models have been trained on. And so they're kind of, you know, what's the line between being inspired by something and stealing it? So, you know, it's a big question. And I don't think there's really a solid answer.
Yeah, I think that there's a lot we
Ongoing
still have to
lawsuit.
figure out in that space.
There is an ongoing lawsuit that some artists sued Midjourney and Stable Diffusion for using their art in training the models for copyright infringement. So we'll see how that goes.
Yeah, and that's not even mentioning the people who like grab these models off Hugging Face. So now they're like a non-company person and then takes a bunch of art from a particular artist to recreate like particularly that artist's style. And now you have like an infinite generator of an artist that you like's style but that's like a whole nother layer of gray area because now, you know, you're just like some person on the internet who took the model and took public art. And yeah, I think it's a big thing that we'll have to figure out going forward.
I think it's interesting. Like, I mean, I did a search. I logged into that Dream website and Dream Studio website, and I searched for like a logo, and it like put like random like letters like in the logo. Like it created a logo, but it's like not in English. You know, like it's not in any kind of language that I can tell. It doesn't appear to be a language. Just sort of like made something up, which I thought was sort of interesting. Anyway, but it's like you were talking about like the text, like it knows that a logo normally has text or has some sort of like figures and stuff, but it doesn't know like they're really text or something. And so it's maybe not really like applying, you know, its knowledge of language to, you know, create the logo, which is sort of weird. So I guess I can share the picture if people want to see it, but yeah.
I've also heard at great length about these models, and I agree that we can often consider them as something that enhances our productivity rather than like replaces something. And so particularly for the Stable Diffusion and image-based sort of models, I mean, the going attitude is that if you're already a graphic designer, like this platform will just like enhance your creativity. But you kind of already have to have like this eye towards things that look really good or where to start. So for like the logo, I know that there are graphic designers that might like start with something that has the letters in it. And then from there, use the Stable Diffusion models to just help them with ideating different changes that they could make to it or something that would look good. But in the end, they end up still photoshopping or developing even what has come out of something like a Midjourney as well into its final product. I guess for people like me, like I have can't do it. Graphic design is just like, can't do it whatsoever. And so it helps me a little bit, but even in looking at some of the creations of our graphic designer, it's just like, I'm gonna be honest, it's day and night.
Yeah, I couldn't figure out how to share the picture in the chat, so I guess I could just share my screen, but I don't know if it's worth it, but that just was interesting, some of the results that came in. But it's cool. I paid a lot to a company to like do some graphic design for me. I'm like, I really like these things that it's showing, and I didn't pay anything, and I just did it in like 30 seconds.
That is fantastic. I mean,
Yeah.
It's fantastic. It's fantastic for someone.
Yeah.
Matthew.
Thank you. So I had another question. It's related to both the prompting of large language models as well as the image generation too, and that is it possible, are you familiar with a way that we can combine both the image and the text in a single model, sort of a multimodal model, so that we can communicate not only by text, but also by images?
So I think it kind of depends on what exactly you mean by that. So there are models that do things like image to text. So they might generate like a caption or some description of the image. Or you might go the other way. So you might have some text. I mean, exactly what we saw with Stable Diffusion. Like you might have some text and then that specifically generates the images. Beyond like, so if you're talking, so those are some examples of what is currently possible. But if you're talking about the scenario that you talked about with Abby, with it understanding like in Stable Diffusion, like writing like words, that I'm not so sure about, although I'm sure, although there could be some possibilities with something like LangChain, where you can put together certain kinds of models, but I think that that would not be some out of the box functionality. That would be something that you would probably have to develop on top of the existing API.
I think what I had in mind was, so right now, if we were to ask GPT or Bing, create an image for me, sort of like you would with Stable Diffusion, it'll say, okay, I'm just a language model, but you can go to Stable Diffusion and more or less do the same thing, say, create this image, and it will. But it would also be nice if you could present an image and say, tell me what this means. Or create or say, can you create an animation that helps me to understand some process X? And there could be then this sort of movie that's going on, and we can sort of, because people communicate in text, of course, but we communicate often visually, but we also communicate in this sort of kinesthetic way. And so I think that it would be really lovely if we could have all of that embodied by a single interface instead of having to go into Stable Diffusion over here or GPT over there.
So I think Umang and Miranda are the ones to comment on with LangChain, whether you can put models of those types together. But I like your idea of generate this image that describes this process, because like I'm even though I can't do any kind of graphic anything, I understand things better through images as well. I will say that there are video models currently that do a sort of classification, which is not as like helpful as what you're kind of describing. So you can look at these sequences of frames. So not as individual pictures, but as the entire sequence. And what it'll do, it will provide a label of the activity that's going on in that frame. But I think this is also where we come down to like the kind of architecture of the model that you want, because it sounds like that model would benefit from having an actual decoder architecture where it's generating the text as opposed to generating like a class. So I think that's an active area of research. On Hugging Face, there are some models that do some video processing and like video to text, but I think that's definitely an active area of research. Miranda and Umang. Oh, I just wanted to ask if you wanted to provide any insights on LangChain for putting together the behavior of different types of models.
I think you can, although I haven't seen it be done. Miranda, have you seen that in documentation anywhere?
Yeah, it's kind of one of those like, sure, try it. With everything's developing so fast that I'm sure someone's going to eventually do that. Right now you'd have to cook it up yourself, but I mean, sure, you could put an input to one model and then take that output and then put that as input to another model, the chain of LangChain. What specific ones I would use for that, I don't know, but I'm sure someone could figure it out, or I'm sure we could figure it out if we took an hour or so to look at it.
Or maybe at the end of this workshop series, it'll be you. So we'll see, Matthew.
Thank you.
There are questions. Omar, I think you had a question. Is that right?
I had a question. This concerns genetic sequencing. I am aware of a method called spatial transcriptomics, which utilizes exactly which transcripts are visible or work. And then for there, you could spatially reason and figure out exactly where in the muscle tissue it goes. And I know that it uses some kind of R programming or Python programming, and some of it's done at Vanderbilt, but I can't find anybody who can help me with it or learn about it.
Well, you're definitely in a great group of people to figure out who that person is at Vanderbilt that does that work. I think if you wouldn't mind, send a message to, I guess, Jesse, and you can CC me if you want to. And I think potentially we'll be able to, I don't know, help hopefully identify who that person is.
Do you have any homework for this session?
I don't think so. In preparation for the next session, you will need, I think this was already in the email, but you definitely need a Google Colab account. And you will certainly want to have the OpenAI account to access, the ChatGPT. GPT-4 isn't required, but it's just kind of awesome if you want it. But those will be the platforms that we're using, but I think that was already kind of specified.
Thank you.
No problem. Other questions?
To Matthew's earlier question, GPT-4 announced when it came out, they announced that they will be able to take images as input and then understand what's going on inside the image. I posted an article about it in the chat, but they haven't released it yet, even in their API. So
Yeah, I think that speaks to something. I don't know what it speaks to, but I think it could be some challenge, and I think it's a challenging thing, especially as they're understanding how people want to use it. Other questions? So I do want to just ask a quick question of you all while you're here, just so I can get a general sense. From our conversation today, it seems like most people are pretty good in programming, lots of experience, maybe, or maybe it was just ChatGPT helping. In general, do people kind of, I guess maybe we can do the reactions. Maybe, so hard to decide what reaction. Maybe a clap if you would say that you're like somewhere closer to like a very advanced programmer, particularly in Python, and like thumbs up if you are a beginner or it's something that you haven't seen like at all. All right, so haven't seen at all. Okay, gotcha. And everybody else seems to be kind of in the middle. Very awesome. All right, that's good to know. Okay. Interesting. All right, well, we'll be here. If you have any other questions, just call on us and we'll be happy to answer. Matthew.
Sorry. Yeah, this is one I would. Do you have, or would you recommend? Are there any identifications that we can make? Because today we talked a lot about prompt engineering, how we can organize a series of statements to control the output of one of these language models. Are there any observations that we could make that would tell us when prompt engineering alone isn't sufficient to meet our objective? And then we would need to transition from prompt engineering to maybe additional layers or levels of fine tuning, or perhaps even to take it one step further and maybe go into the reinforcement learning arena.
Interesting. Yeah, I think that is a very empirically question currently. I don't know, other people may have other opinions, but I think that generally, so one thing is that even if a model isn't like very intensely trained, on some domain, it could be possible to supplement this model with just documents that help it to know the answer. So I'm not talking, I mean, maybe something as large as like a textbook as like a document store. And so now instead of the model using only like this very specific context that you give it and its computational abilities that are embedded within its like weights, you also have the ability to pull context from this entire document. So now you're supplementing its knowledge with the information that you want it to know, but it can just pick and choose which pieces of that entire textbook that it actually wants to pull into answering the question or doing whatever task that you want. So I think that's another avenue that sort of has to be explored. When it comes down to fine tuning, sometimes if you're thinking about a model that is doing a very specific task, or it's in a very specific domain, you can leverage smaller models. So instead of having something that is as large as GPT-4 or GPT-3, you can go to something that's third size, which would be a lot smaller. You can train it on smaller compute. But in terms of knowing where the line is, I think there are ways that we can, augment the capacity of these generative AI models. But I think it's empirical still. I did see, so one of our colleagues shared a really great paper with us about bias in AI models. And so the way that they went about quantifying the relationship between how actual people respond in surveys versus how if you treated all of those, or if you replaced all of those people that are in normal surveys with AI like representations of them in terms of persona, they found that there is a distinct difference. And so I just think it's really interesting the way that they went about quantifying those differences. And I think it could be instructive when you want to go about quantifying things that are going on in your language model. The professors are Josh Clinton, Cassie Dorff, let me see, Jim Bisbee. So if you want to look up their paper, it's absolutely fantastic. Emmanuel.
Yeah. Okay. Yeah, I actually have a question on. I'm actually doing a thesis on machine learning. My plan is to analyze a set of data using the idea of clustering techniques. So I have like a set of data of about 26 or 27 data sets of different locations in the US here. And the plan is to use the idea of machine learning to analyze the data using clustering techniques, looking at k-means clustering and hierarchical clustering. So I went ahead and decomposed the data into trained data and seasonal data. So while analyzing the data, for the k-means, I try using the idea of the Jupyter notebook, but I realized that there was this error in one of the code talking about insufficiency in the memory. There was insufficiency in the memory. So my professor suggested I should use what is it called, Google Colab, which I used, and it's still, giving me an error, telling me that there's a crash in the processing. So it's actually suggesting that I should use Google Colab Pro. So at this point, I'm kind of stuck in my analysis. I don't know what to do, So I don't know if there's any suggestion on what I can do to do the k-means clustering.
So something that I always love is, I love to suggest now is, especially if you have access to GPT-4, I would just put the code and that error into GPT-4 and ask it what is wrong. You can even describe like the computing platform that you're using. So like Google Colab. I have my suspicions about how the memory is being managed, and you can refactor your code to be more memory efficient. But I think with GPT-4 in particular, it will be able to tell you about where this error is coming from. And if you keep interacting with it, asking it things like, well, in what ways can I rearrange this code so that would be more memory efficient? Or can we you be like the kernel, and then I will just like give you these inputs and you tell me the outputs or something. And it can help you to understand where the code is going wrong, but also help you generate code that will take into account the size of the memory that you have.
Thank you.
Yeah, also it may recommend other approaches. I had a really great experience with it the other day because I was trying to do something in R and it was just not going well. It was going terrible. So I was working with it to try to figure out. And after a while, it was like, you should just use this other package. And I was like, I didn't even know such a thing exists. And it was like, yeah, just try this code right quick. And so I tried it and it was like perfect. So sometimes it comes through also with great suggestions about other approaches, just flatly.
Thank you.
It's a good question. It's a good question. Some other questions. If you need something from us, we'll be right here. Just call on us. We'll be here.
So at the conclusion of this program, I know there's a plan is to have at least some project kind of presentations at the end. Is that correct? But will there be other workshop type programs? I'm not familiar with this kind of workshop. Is this something you guys routinely kind of have throughout the year, or is just like a special summer thing for the month of May, or what is the plan going forward?
So both. So we have, I think for the last 2 years, had this thing that's called AI Summer, which is about transformers. And this year it has been, was it three something? I don't know. But this summer it's about generative AI in particular. And so this is something that we do have every summer, AI Summer in the month of May. Also, we have something that's called AI Winter. And so it is not the 4 weeks of AI Summer, but it is one single week during the winter. So usually at the very beginning of the year where we go over similar topics, but in a very condensed form. Also throughout the year, we have plenty of workshops and seminars where we talk about different topics, and especially the ones that are pretty emergent or they come up suddenly, like ChatGPT, GPT-4, how they just like arrive on the scene suddenly. Let me see, maybe a good thing to look at would be the Data Science Institute. We have a calendar of events that you can also use to just see what we're up to and what will be the workshops that we'll be doing. Let's see. So it's the best thing generally to look at, and actually that I look at the most, just to see the new things that are coming up, is the newsletter. But in case you want to know specifically about things that are going on in calendar form, also have this. All right, just let us know if you need something. We'll be right here.
So I just signed up today. I have not been sent any message yet. I actually got the link from my friend, so I don't know if I'll be sent a message to my email.
And is this just generally OpenAI?
Sorry?
Is this just OpenAI? Is it ChatGPT, ChatGPT Plus?
No, I mean, I just signed up for the workshop today.
Oh.
Yes. So I have not received a direct message email yet. I got the link from my friend.
Oh, good friend.
Yeah, so yeah, I'm actually expecting an email from the organizers. Yeah.
Let's see. Luong or Miranda, do you know if you want to, you might be able to manage that?
Yeah, so I think we could send an email, like, yeah, the emails were sent out more broadly, like of just the list of emails that we had. So since you just signed up today, I haven't sent any emails today. So,
Okay.
or I'm probably since you signed up. So,
Right.
but we can make sure that you're on that.
So there's an email list that he can be added to. Awesome.
Thank you.
No problem.
I had another question. In you guys' experience, what certain, I guess, broader categories of tasks are these generative models good for? For example, if you ask, bring me all the information there is to know about a specific thing, then it will fail at that because it will omit some of that information. It won't be able to bring all the pieces. Or if you ask for facts and stuff like that, then it's not the best for that. But it is good at summarizing texts, for example. So what kinds of applications are these models good for?
Do y'all want to take this? Well, Miranda, you can even talk about the projects that you've done because those have been really great.
I am having a bit trouble hearing you, Devere. The volume's really low for me and I'm crunching on almonds. So I may need you to repeat that, or your microphone needs to change or something.
Can you hear me now?
Still the same volume for me.
How about now? No, still?
Oh, that's better.
Okay. So my question was, what specific broader categories of tasks are the generative models good for? For example, if you try to get facts out of the models, it's not very good at that because it misses some of them or makes up some, but it's good at summarizing text, for example.
So when it comes to the facts part of it, I wouldn't say it's necessarily bad at it. It really depends on how, again, you ask the question. It comes down to a little bit of prompt engineering and pointing it in the right direction. So, if you were to ask, give me all the facts about this thing from this Wikipedia page, and it has the ability to access the Wikipedia page, then it'll do a fantastic job. But if you were to just ask, like explain to me the concept of, I don't know, particle physics or something like that, it will be more likely to hallucinate because it has a little bit of freedom and it's not necessarily referencing something. It's kind of just going off of what it was trained on. Bing Chat GPT kind of solves that problem because it does have access to the internet. It can I think it has, in its process of generating results, it goes through some sort of a verification process where it checks that its output is correct. Things like Auto GPT actually are designed to do that, where it generates a result and then it goes back, verifies the accuracy of the result, and only then gives you an output. So using additional tools and augmentations like LangChain really allow you to do the things that it would otherwise not be good at. That being said, I think it can do a vast variety of things when given these tools. I think the biggest limitation is for it to be able to access those tools, but LangChain allows for that to become a lot simpler, and we'll definitely cover a wide variety of applications with that next week.
Yeah, I think my headcanon for thinking about, ChatGPT and all of this is, if you are walking down in a city and you pull a random person off the street and ask them a question, do they know what they're talking about? Maybe. Especially if you happen to get a scientist or something, because this is all compiled from the internet, right? So like if you ask someone on Reddit these things are really good for, generating ideas like, oh, give me ideas for a story that does this, or write a poem in the style of this person, and you know, a person could generally do that. Yeah, asking someone to summarize a document, they probably could do that too, but then asking them to do math, maybe not so much. So whenever I think of like, what can I do with this, I tend to think of, if I pulled a random person off the street, what could I ask this person to do?
And what about logical deduction?
I found that GPT-4 is really good at logical deduction. I mean, I think it can pass the LSATs with a 90% accuracy. At least that's what I saw last time I checked. And I mean, that's better than most lawyers, I would say. So yeah, I think it's good at logical deduction. GPT 3.5 probably not so much, but GPT-4 for sure. And it's just because its size is so much larger in terms of parameters that it comes up with these like abilities. I think Jesse has a better way of explaining it. I can't remember the term that he uses, but it's better because it's larger.
Have you guys had any experience with other models like Llama or those kinds that you need to run yourself? Or no? I wonder how those would perform compared to GPT-4, specifically with logical deduction.
I'm particularly interested in alpaca and then this red pajama situation. I do like a smaller model because I like to run things locally. And also because so many of our projects at the DSI end up being these projects where they're working with medical data or working with things that have these data use agreements, or you can't just put this person's research anywhere. And so I do love a local model. I forgot where I was going with that. Oh yeah. So I'm really excited about using alpaca. I think at the time that alpaca burst onto the scene, the issue was that the creators would not release the model weights, or they released the model weights and then they were just kidding or something like that. And so we didn't have access to them. But I just haven't checked since then. But I'm extremely excited about alpaca.
Yeah, that's exactly the situation I'm in. Medical data, cannot put it into ChatGPT. Now there's the Open Llama project from Berkeley that they've trained it on 300 billion tokens or something, and they released a checkpoint, and now they're training it on the rest of the data set. I don't know when that's gonna happen, but running that model, it still has some ways to go. It had very funny things to say when I tried it.
I think also, I'm not sure about it though, but it just depends also if it's had the final little pieces applied to it, like the reinforcement learning.
I think it did specific. Well, maybe not, because what I gave it a prompt, hello, my name is, and then continue. And he said, hello, my name is James. I'm a 17-year-old male. I was diagnosed with autism at 3 years old, and then continued rambling. And then he said, I'm good at socializing and I'm good at making friends, which is very interesting how he forgot what he said about autism just a second ago.
Maybe it's all going together for that particular, I don't know, embodiment.
Yeah, I mean,
Maybe.
It's not impossible.
No, It's not impossible, but it's interesting that that's what it said. So I'm guessing maybe it's the data it was trained on up until that point. Maybe it was reinforced in some way to generate some kind of output of that sort, but who knows?
Yeah.
Well, actually, it's an open source model, so we're supposed to know.
Yeah, we can go know. But I will say the thing about some of these models is when they release the models, they release the base models. And so that's something that we've seen on Hugging Face a lot. So you'll have something that's outstanding conceptually released from somewhere like Big Science, and it's huge model, pre-trained, fantastic, but it is this base model. So the base model is sometimes would not have an instruction sort of fine tuning. So it's not going to be able to understand task really well. or it doesn't have this reinforcement learning from human feedback. So it's like they've trained the base part of it, but then still a lot of the work is still left for the user.
Can I ask a question sort of following up on that? Has anyone here ran one of these models on like a personal workstation? Or is this all just cloud? Because it would be nice if we could have a smaller model that we could sort of operate on locally. Has anyone been able to do that? And do you know what kind of resources would we need as individuals if we wanted to do this?
I think Alpaca is something that you can run. You can train it. What is it saying? They trained it for $600 using 1 GPU or something like that. And so that is something well within the range. So if that's what it takes to train, then the inference is going to be much lower in terms of computational demand. And so I think Alpaca, that's why I'm like very excited about Alpaca, because I want to train it essentially for me. Like I need it to know me so it can help me write things like a little bit better. So I think that's something definitely to be pursued. And I think there's some other models that are also newly released. I just haven't quite had time to look into them. But I think the other models are just way too large. Something that has been interesting though has been exploring. So someone was talking about the different checkpoints of the models, and also the fact that they have different numbers of parameters for sometimes the same kind of model. I think we had an interesting exploration last summer with, what was that? GPT. I think it was the open source version of GPT, but it was GPT-2. And then there was like a 1.7 billion parameter model that we could run on Google Colab, which is, I mean, Google Colab like free. So that's something that could possibly, I think that's something that can be done on a workstation. I think it was done. I think I've done it on a Dell computer that I have, but it has a desktop that's in it. Or sorry, not a desktop, a GPU card, like a dedicated GPU card. But then once you got up to like the 7 or like something, once you got up to like the larger versions of it, then it could no longer run locally. So I think it's also something to be said. I mean, like we were saying, the size of the model, but sometimes you just have to choose smaller capacity models if you want to run them locally, unless you just have some huge amount of compute. And so are you at Vanderbilt?
Me? No, I'm at it's actually a place called South College. It's in town.
Okay, if y'all have some computational, I don't know, area or I don't know, computational like area, like center on campus, that if it has GPUs might be able to contain like a smaller size model, something larger than like the GPT-2 that we're using, but certainly smaller than the current GPT-3 or GPT-4.
And you made a point that really struck me, and I wanted to ask you about that. So you were saying you wanted to train Alpaca to know you. How do you accomplish that? How do you train a model to know you?
Okay, so I don't actually want it to know me. I don't want it. I want it to do like how I write or
exactly.
the things that I like to do. Yeah, it's still a decision that I'm trying to make. I don't know. I always want it to be, first of all, I love chatbots, period. I just love talking to them. I just think it's really fun, which is super awkward. I don't even know. I don't know what that says about me. But I would love to talk to one that would know like my interests. So there are some that I have tried that are like having small talk all the time, which is like awful. And there are some that are amazingly rude, but yet it's interesting to talk to them. And so I'm not quite sure which one of those extremes that I prefer. So I prefer something in the middle. Do I want to talk to myself? Not sure, but I want to give it a try. I think it could be interesting. But I do want it as like an assistant that would say the same things that I would say, or do or take action. So I don't really like them taking action, but propose some action that would be in line with what I would expect. Just something that's more tailored to what I sort of need it to do. So something that when we get to the point that they can generate like some sort of PowerPoint or something like that, it's going to generate that in the way that I would do it, as opposed to just some generic way that someone would do it. So that's kind of Small talk with Skynet. Don't do me like that. But yeah, I just wanted to be able to do tasks that I would do in the way that I would do it, as opposed to some generic thing.
And do we know how to accomplish that? Like, what would that training routine look like?
I think it'll just look like training it on the things that I have written. And if it's a PowerPoint presentation, like how that looks, especially when we get to image. I would also like for it to take care of like tasks, but it would also have to know how I do those things. I really just want it to be my personal assistant. So in general, like I would like to collect data just about myself and the things that I do when, and I need it to just be telling me things that are important about that. So yeah, I think it's just going to be a matter of just collecting things that I've written, or I don't know, text that I have available for it.
And sorry, I don't mean to ask so many questions. This is really interesting to me. Could prompt engineering do that? Like, could we do like like a sort of a few shot example, like the in context learning? Would that be sufficient, do you think? Because or would we actually need to go back and do maybe a reinforcement learning sort of approach? Because there are a lot of examples where the amount of reinforcement learning information is very, very small compared to the massive corpus, but yet it's able to learn and actually do quite well. That goes back to the question I had earlier. When does prompt engineering end, and when do these others begin? Because I want to know the answer to that question.
Yeah, my impression is when you can no longer, I don't know, prompt engineer your way to a good answer. I'll say, like, if there is a model, so I anticipate that another way that I would train this model is just simply by interacting with it. So it needs some sort of like history. And there's going to come a time where the context is too long to fit in the context that, I don't know, Alpaca or whatever would be able to access. And so then, of course, I would move into the document stores. And when all that failed, I think it'd be a great idea to try to train it. But if the computational ability to train it is available to me, I will also just try to train it directly. Yeah, could be interesting. I definitely don't want it to be me, although I do know some people that want it to be them, like the representation of like who they are, that they might like give this AI model to like their kids or something when they pass. So I don't know if I'm all in with that, but there are thoughts around that. Other questions?
Matthew, for your question earlier about running the models locally, that's the model I was talking about. I ran it locally yesterday, and it's the same size as Alpaca. I'm seeing now 7 billion parameters. I don't know how they measure that, but 7 billion something. But if I have a GPU that's only 6 gigs of VRAM and then another 16 gigs of RAM on my laptop, and I managed to run it. It took a long time to load the model and then like 20 minutes to answer the prompt. But if you have, I think 32 gigs of VRAM on a GPU would probably be sufficient for those models. And Hugging Face Accelerate is your friend. Very good library.
Yes, so true.
Thank you. I appreciate that.
Interesting. You are so right. Ooh. like my time is quick. So I can llama it up soon. I love that.
And Devere, was it difficult to get this to run? Did you have to go through a lot of hoops, or was it pretty straightforward?
Oh yeah.
Oh,
It was pretty difficult, but the main difficulties was getting PyTorch and CUDA all set up. But once you have that, you're pretty much fine. And working with the what's it called? With the limitations of my hardware. If you have more hardware, you're better off.
I've heard a little bit about Lightning AI as well. I think I don't know if you're familiar, but it sounds to be similar. I'm not familiar with Hugging Face Accelerator or Accelerate, but Lightning AI helps with that piece of having, spreading the model out over your GPU, or it carries out that dialogue so that we don't have to.
PyTorch Lightning? Is that PyTorch Lightning?
Yeah.
Yeah, usually, so Hugging Face has, in their training, they have similar implementations. And I think you can also use Lightning some in Hugging Face implementations. Yeah, they do data parallel, distributed data parallel, and so it's really nice. So if the model is on Hugging Face, it's good to know.
I think Accelerate specifically also knows how to handle Onyx models. So even if it's just a PyTorch model, a TensorFlow model, you can convert it and then it would work too. I'm not sure, I never tried it, but I think it can. But Accelerate is nice because you just specify device equals auto and then it works.
When you were getting your PyTorch and CUDA set up there, did one of like ChatGPT or did you find that useful in helping you track down the problems?
Not really, because all of this is, well, PyTorch and CUDA, I just used a Docker container for that specifically. But downloading the models from Hugging Face and then getting it all to work with Accelerate library, ChatGPT couldn't help me with that because it's all too new for it to know. So if I wanted to use it, then I'd have to use Bing GPT or something for it to pull the data off the internet, like the documentation and stuff. And until today, I didn't know that existed. And I will say their documentation is lacking. So I don't know if ChatGPT will be able to help you with that either.
For Alpaca? For Llama?
No, for Accelerate and for all that stuff. Hugging Face's documentation isn't the best.
When they update it, like it seems to be like really, I think I don't know, since they're like always like adding new stuff, some parts of it are just like very open.
Yeah, probably. And LangChain, same deal, but it's also super new. So
yeah,
priorities, I guess.
Exactly. I think so, the same thing. And I guess they figure like if push comes to shove, you can just look at the source code.
That's what I did.
Yeah, they have
to
nice-
figure out the parameters for
Exactly.
accelerate and stuff like that. Just look at the source code.
Exactly. And then that's when GPT-4 is nice, because then you just copy and paste whatever you're looking at and be like, what's going on with this particular variable, blah, blah, blah. So I'm with you. This is awesome. Interesting. Oh, all right. Well, I think we're at our final time. Thank you so much for coming and for the info on alpaca versus llama. I was not having that correct in my mind, but now I know, and I'm really excited for this weekend. All right, so I will see you all on Monday. Bye.
Thank you.
Thank you.